Primary engineering controls include horizontal and vertical airflow workbenches, biological safety cabinets, and isolators. In most cases, facilities use a laminar airflow workbench to provide the environment for critical sites. All of the primary engineering controls are designed to maintain an air quality of ISO 5. The barrier isolator system uses a technology to minimize personnel contact and separate the external environment from the critical site. Compounding aseptic isolators are used for the preparation of non-hazardous CSPs, while compounding aseptic containment isolators are used for hazardous drugs such as chemotherapy. An isolator can be a useful alternative to a traditional laminar airflow workbench in a clean room, but the isolator must be supported with proper operation, maintenance, monitoring, and control procedures. Achieving, then maintaining sterility and a contamination-free environment results from the quality of components, the compounding process used, environmental conditions during the compounding process, and, most importantly, personnel performance. Primary engineering controls are placed inside another environment called the secondary engineering control or buffer area. If the buffer area meets air quality, HEPA filtration, air changes per hour, and room pressure differentiation criteria, it's considered a clean room. Secondary engineering controls also include the Ante Area, the environment just outside the buffer area. Primary and secondary engineering controls are considered classified space and must be certified by qualified personnel at least every 6 months. One measure they test is air quality. Air quality is classified by the number of particles of a specific size per volume of air. Primary engineering controls must meet the standard of ISO 5. The buffer area must meet ISO 7, which allows more particles but is still very clean air. The Ante areas must meet either ISO 7 or ISO 8, depending on the type of connecting buffer area. Bringing an existing facility into compliance might require replacing existing flooring with seamless vinyl, installing HEPA filters, replacing ceiling tiles with plastic-covered cleanroom grade tiles, and minimizing or eliminating refrigerators, computers, and printers from the compounding area. Sometimes a primary engineering control must be placed in an area that does not meet USP 797 requirements for a clean room. This might happen at a pharmacy that does not have the space or resources to create a clean room, or in a pharmacy satellite to supplement a clean room. In these situations, a primary engineering control may be placed in a dedicated space outside of a clean room called a segregated compounding area. Let's take a quick tour of a typical compounding environment. Here's an example of a clean room or buffer area. Note that the room is free of any extraneous devices or storage. Here's an example of an Ante area. Following USP standards, an actual Ante room is not required when compounding low and medium risk level CSPs. A separate Ante room is required for high risk level compounding. The Ante room provides a clean area for hand washing and completing the final checklist of hair and shoe covers, gowns, gloves, and masks. The Ante room should include a hands-free sink, and compounding personnel must be able to enter the buffer area without the use of their hands. Here's an example of a segregated compounding area. Note that it's in a functionally separate area from other activities and must be in a low traffic area to minimize air turbulence. Maintaining your facility's risk level requirements is an important part of your daily routine. Areas where drugs are stored, including refrigerators and freezers, should be monitored to ensure that temperature, light, moisture, and ventilation remain within manufacturer and USP requirements. All IV solutions, drugs, supplies, and equipment used to compound or administer CSPs should be stored in accordance with the manufacturer and USP requirements. For all risk levels, the policies and procedures you establish must be consistently followed to be effective.